Much, and thank you for having me. My name is John Pierce. I come from Austin, Texas. So my background, I work for IBM. I'm a product line executive, so I'm responsible for all the security products in IBM Internet Security Systems. Prior to that, I worked for Cisco and their security and technology group. And then before that, I worked for the US intelligence community doing IA. For me, I totally love security, so I'm really glad to be here. I wish I could be showing you how to hack into Amazon EC Cloud today, but we won't be doing that. We'll be going kind of over the risks. So what I'm going to be talking about is kind of the security equation, why that's kind of important to kind of understand that before we start diving into the cloud. What is it? What are some of the various cloud models that we'll be talking about? Why are they important? Why are they out there? Is any of this stuff really new? We'll talk about virtualization, as virtualization is very much a key component to cloud computing. There also is it introduces a lot of different risks with the cloud that we'll kind of go over and we'll talk about. All things that can be mitigated. We'll talk about embedded virtual security and why that's important when we start looking at securing virtual frameworks of tomorrow. And then we'll have a quick summary and then some Q&A. So when we look at security today from all of us in this room, I mean, the equation has completely changed. When we looked back in the early 90s, late 90s, even early 2000s, having security was a great thing, a firewall, access control and segmentation. All these things were best practices. And you've seen all these different types of point solutions pop up here and there. But what we're dealing on more of a global perspective now is a lot of the regulatory compliancy that we're seeing. Compliancy that's not only just with respect to PCI DSS, but we're also talking about legislative, country regulations, et cetera, where data can't even exceed country borders. So it's been very interesting of how it's driving security and driving it in the infrastructures that a lot of us work in today. When we look at the economic crisis that we see that's going across the globe, it has really driven and been a primer for virtualization and cloud computing. And again, which is a great thing because it's an emerging new technology that I think we can all take advantage of. But again, understanding the risks of putting all your data up in the cloud, I think, is really important. When we start talking about the threat landscape has absolutely changed. When we start looking at how the attack landscape was, again, of the 90s, early 2000s, it was pretty much directed attacks. Let me try to get in your network, et cetera. Targeted OSs, applications were ones that were really focused. But what we're seeing a lot today from a lot of our research is a lot of that has changed. I mean, now the client, it's all about the web browser, it's all about server threats and web applications. When you start looking at the proliferation of the internet, how it's being used, we used to deal with very static environments, one way into a network, one way out. Nothing was really transforming. Today we're dealing with dynamic infrastructures, new coding, et cetera, things that have not been baked in for such a long time, introduces a lot of risks. So what we've done from our X-Force Research R&D is we put out trend reports every year. And what we did is we just, I'm focusing on a couple things here because I think these are important. When you start going up in the cloud, everything is webified. But it's important to note when we start looking at server-side trends for attacks, we've seen such a massive uptick in 2005, and even in the second half of 2009 on the attack vectors on web applications has been extremely enormous. But when you look at the different type of server-side attacks, cross-site scripting, SQL injection, I believe there'll probably be a talk on SQL injection after mine. But when you start looking at, these are average daily attacks by month. What we have is we have 8 different SOCs located worldwide where we get a lot of this information, so it's really great. So we're getting this information, statistics and trends out of EMEA, out of APAC, out of the United States, out of South America, Australia, et cetera. But again, the reason why we see such a proliferation of SQL injection attacks is it's low-hanging fruit. There's a lot of people that are or a lot of organizations that are online, putting their web resources out there and really not checking them for any type of security vulnerabilities. But again, these are important because as we start traversing in the cloud, these type of trends and statistics can be quite alarming. But when we flip over on the client side, we've seen a massive change as well. So as you can see, targeted from an OS perspective, those attacks have kind of started deprecating. They started to deprecate more and more as we start going in through the year. But what's really on the rise is the browser, the web browser. So a lot of you are probably familiar with iframe injection, drive-by malware, et cetera. All these things are real. And when we start looking at just a specific vector here, we start to look at document format vulnerabilities. And we look at the Office format, and we've kind of seen a dive down in that. what we've seen pretty much an escalation on is basically the PDF vulnerabilities that are out there. So as we all know, all the web browsers that we have today, Safari, Internet Explorer, et cetera, all of them have plugins, browser-based plugins for PDF. A researcher of ours, Mark Dowd, actually found an exploit in Adobe, the Adobe Flash plugin vulnerability. Ever since we released that paper, we've definitely seen a rise on just those specific attacks, but we've seen a lot of different of those attacks kind of go into different areas and with respect to browser-based exploitation. So again, all these things are important because when you start looking at the cloud, which we'll be talking about very soon, is basically, all of it is basically server side, and then accessing this is basically through your web browser. So understanding where the attacks are, the landscape, et cetera, how that's changing, really needs to change the way how all of us think and how we do security going into the future. When we start looking at virtualization vulnerabilities, so basically what we've done is we've gone back in our X-Force database research back almost 10 years ago. But if you start looking at, early 1999, there was, very little attacks out there, but very things that were trivial. Buffer overflows were big back then. As we start going through the years, no system, no vendor is immune to any type of vulnerability or exploitation. But as we look at VMware, as we start coming through to 2005, 2006, as you can see, how this has escalated in 2007. We'll be having some further dates that come out to 2009. But what's important to note is if you were to take this and put this over the web application vulnerabilities trend slope, you'll see that they're basically almost identical. We go through here again, Microsoft Virtual PC. So we kind of cover all of them. But what's important to note is that we talk about the web application vulnerabilities, client-side, server-side, and now the virtualization vulnerabilities. And then the last one. So basically doing a basic dot, trying to do breakouts, trying to get out of the same virtual machine, trying to gather data, et cetera. All these things are possible, but becomes more and more important when we start getting into the cloud. We'll be talking about multi-tenancy, isolation, et cetera, why things like SE Linux, SVIRT, all those things are important, and we'll go into details on that. But again, a lot of these are trivial, but these things can happen, and these things are important to keep our eyes on as we start getting into virtualization. And really quick, can I see a show of hands for any of your infrastructures that are doing a lot of server virtualization projects right now? What about virtual desktop infrastructures? Rolling those out, VDI? 1, 2, okay, excellent. So I'm not going to kill you on compliancy, but I think this one's very important. I actually talked with a client here yesterday, here in Sweden, who's a multinational company who has presence in the United States. But obviously, what's really cool about compliancy from a security perspective is organizations have to follow them. They have to have certain type of security checks in place. Obviously, meaning that you're compliant doesn't mean you're absolutely secure, right? It's a matter of how you deploy it. But in the United States, we have PCI DSS, which is a payment card data security standard. And there's basically 12 different requirements that define how you must basically secure a network to handle payment card data. Now, this becomes even more important because there's a big compliance debate in the cloud. I don't know if some of you are familiar, but there was a blog that was released on Amazon that talked about they were not able to handle PCI DSS Tier 1 clients. There was since been an update saying that they do have the capability to protect data, PAN data in the cloud. I think that's important in understanding, okay, well, if we look at these different 12 requirements, you can take a look at them. Obviously, it's very boring to read all these, but when you start going through them, they have very specific requirements that you must have, right? But it's important to note when we start doing business in the cloud or offloading certain of aspects of our infrastructure in the cloud, these sort of things become important if compliancy really is something that you have to adhere to. Now, I just give PCI as an example, but different countries have different compliancies to healthcare. I was in Luxembourg and was talking to a couple corporations and a journalist there. Obviously their client data cannot, or financial data cannot go past their country borders, right? So when you start talking about cloud providers, et cetera, a lot of these things have to be co-located in the countries that they are serving out the different cloud services. But what I wanted to do is just basically kind of go over what's the threat landscape, what are we seeing? It's absolutely changing. When we start looking at security, it's no longer I just have a firewall in place and some AV. Those things are good from access control and segmentation and kind of keeping the noise down. But when we really start looking at architecting and building out these different solutions or placing our trust in a different provider, these questions must be asked. because today your information is worth a lot more, than destroying it. I mean, as we see in the different presentations here, as far as being able to pull data from your passports, et cetera, all these things are important. They drive a lot of different things from the underground perspective, cybercrime, cyber terrorism, et cetera. But when we start coming up in the cloud, all these things start really coming together, because what we're really dealing with is everything that is online, on time, every day. So when we start looking at what is the cloud, you can probably ask several different vendors. Probably everybody in here might have a different version of, what does cloud mean? Cloud should probably not be new to any of us who have Hotmail accounts, have used Instant Messenger. All these things reside in what would be the cloud. But today, what is the cloud being used for? So we're seeing a lot of different corporations that are putting a lot of their, maybe not their corporate confidential data, but whatever they can offload, right, to the cloud. They may be doing this to expand networks, to expand availability, to expand disaster recovery. And these things become important because what the cloud really provides you from a security perspective or just a basic IT is a couple things here. I mean, rapid provisioning, advanced virtualization. It gives new businesses a way to meter and bill you based on usage, right? So based about the amount of bandwidth that you're using, the amount of storage that you're using. And again, from a CapEx perspective and what we're seeing from an economics perspective, this is really starting to take off from the perspective of a lot of different companies. But the question's always being asked out there, well, what do I really want to store in there? And when you start looking at the various cloud models, you have your enterprise IT, your enterprise cloud, and public clouds. And basically, you can break it up into private public clouds. But when you start looking at, well, what are some of the different services that are coming out of the cloud? And a lot of these things are starting to take a lot more definition. But you have platform as a service. You have infrastructure as a service. So for example, I've been working very closely with a company in the United States called BlueLock. Pat O'Day has done a lot of speaking for VMware. Basically came up with infrastructure as a service. But basically what they do is they offload all IT infrastructure to a lot of their clients. But what's really important in working with that company is really their focus on security. Their focus in understanding how they can keep the data separated, how they can keep it secure, isolated, encryption at rest, et cetera. And there's been quite a few challenges for them. I mean, back in the States, we have what's called SAS 70 compliant. And within SAS 70, that actually gives you a lot of different ways to, follow kind of a checklist of the different type of security that you must have on your network in order to have some sort of service cloud. And then working as a software as a service. In each of these, I'll start talking about them as we go through, but each of them kind of has their own different type of security level. How much security would you be expecting to be had at each one of these different type of service levels? But when we start looking at public clouds, again, putting your critical IP, putting your customer data, et cetera, it's how risk adverse you are and understanding, what security do they have. If I knew the security was absolutely good, I understood everything that they had, I would probably feel safe with it. But it really depends on where it's located, who has it, et cetera. And you'll probably start seeing a rise of different type of cloud certifications, right? And I think that's probably going to be important as we go down. But when we start looking at, well, then if we don't want to do public, but we want to have our private cloud, which is basically in your infrastructure, your data centers that you have today, and is basically outsourcing that and having other people run that for you. But in that way, you do have some control of what they would call the cloud. So why is security important? So we live in a global economy, doing business all over the world. So obviously strategic outsourcing, grid computing, Web 2.0 collaboration, virtualization. You have all these different buckets, right? All these different type of IT models that all of us have to look at. And from a security perspective, a lot of it probably doesn't seem that sexy, right? But from all of us in the room that have to do security, understanding the business of why we do security is absolutely important. It's just as learning how we'd have to hack into some of these and protect them. So when we start looking at, well, what are some of the risks that we have to deal with when we start looking across the spectrum of these different buckets? So I mean, strategic outsourcing, so it's vendor trust. Can I trust that vendor for having my data? Outsourcing, so there's a lot of different legislative boundaries. I talked about a couple of those earlier, but more specifically like Luxembourg. For example, identity access and management really come to mind on that. Because the question that came out of there was a talking to a bank there where, their email system went down and they had to get data out, and the question came up to me, well, what happens if they pulled up their Gmail account and sent that email that had confidential data? I'm like, well, yeah, now your data is going to reside in Mountain View, California, which actually traversed the border, et cetera. But again, all these things are important to understand. The web threats that I talked about, the web threats that I gave you the trends on, and there will be a talk on SQL later after this talk, they're real. I mean, this stuff is not theoretical. We see them all in our SOCs on a day-by-day basis. But it's important to understand those and understand why you need to protect, why you need to have more than just a firewall, why you need to have deep packet inspection, et cetera. Data leakage is kind of like how cloud is in 2009. Last year, everything was all about DLP. As we know that the first time that we actually connected to the internet, you had a DLP problem. Except this time, before was kind of breaking in, hacking, defacements, et cetera. Now I want to break in, I want to patch myself, and I want to pull as much data as I can, because your data is very important. And then we get to virtualization, a shared infrastructure. So when we're doing virtualization in the cloud, is my data, just co-located on one hypervisor where I have only my data, on one system or one blade? Is my data shared? And if it's shared, then what's going on? How is it being protected, and how is it being isolated? So when we start looking at the different security concerns, how do those map up to the different risks, right? So making sure we have SLAs, making sure that we have web security, data leakage prevention, and isolation technologies. I really won't go into great detail on the isolation technologies, but what I think is really important is understanding the different types of hypervisors that you can use. Obviously, VMware, Xen, there's a myriad of different technologies that you can use out there. But things like SE Linux, being able to do access control or setting labels on the different virtual machines from an isolation perspective become extremely important, and being able to do that, and that isolates out the data so there's no cross-contamination. So there's a lot of risks. There's a lot of different security that we could put in there. And really going by why this is important, there's no silver bullet, as we all know. What I think is kind of funny about this reminds me of a story when the first time I really got into security about 12, 13 years ago, and I built a system, secured it, I briefed a bunch of my senior officials, said, yeah, this is great, I secured it, it's unbreakable, et cetera. So I talked for a while. When I came back down, my mentor at the time sat me down, he goes, man, you shouldn't have said that it was unhackable. And I'm like, well, why is that? And he goes, well, see those guys across the room? These guys wave at me, and they're like, yeah, they just pumped 50 holes in your architecture while you're up there speaking. So what's important to note is there's no silver bullet. There's nothing that's not hackable, right? It's just a matter of how you're deploying your security and how much risk that you're willing to take, right? And understanding the technologies that you're going to put in place. Because as you've seen, we've had a lot of smart people up here who actually do the embedded hacking, et cetera. There's a lot of things that are possible, right? And a lot of things that are basically really hard to stop, right? But understanding what you're putting in your infrastructure, what you're securing, and what you're putting up in the cloud, all these things are important, because all security is not created equal. So Cloud Security 101. So today what we're really dealing with is obviously our infrastructures that we have. They're wired, they're there, we can see them, we can touch them, we can feel them, et cetera. Gives us a sense of ownership or a sense of control, right? But when we start going into the cloud, a lot of that changes. Who has control? Where is it located? You talk about migration, vMotion, et cetera. Could some of this stuff be being co-located into another country? Is it backed up? What are the backup processes in the event my data gets destroyed or lost? How resilient is it? Does our security team engage? All these, again, are extremely important questions to ask, because you don't have control, you don't know what's going on, and you do want to have an idea of what these are. Now, all of us in the room here, being security professionals and being in the industry for a long time, for us, this is not rocket science. We understand to ask these questions, right? But when we step back and look at, I would say when you look at the security industry, you have, this 80-20, 20% that are highly technical, that really understand the industry. I think we have a lot of them here in the room today. But you have 80% that are generalists that don't understand, that wouldn't know to ask these questions, right? But I think it's more from an educational perspective to understand, where we're at today, where we're going tomorrow, and the right questions to ask. And again, I mean, these are lessons learned. I mean, these are questions that, again, we've had to respond to before, right? But it's understanding of how fast we can respond to them when we start going into the cloud. And at a high level, I mean, these are some of the concerns in talking to a lot of the big Fortune 500 companies around the world, and talking about, well, do you want to go to cloud? What are some of your biggest concerns? Obviously in the US, compliance is really huge. I mean, how do you do compliancy in the cloud? Do you send an auditor to do that for you? Do you trust that they have all the basic regulatory checks in place? Because it becomes important because in the United States, if you're not compliant, it costs you money, right? Before compliance was really a big issue in the United States, if I got hacked, it didn't cost me money. But there's a retail organization that actually was PCI compliant that had a breach, and they've had to spend $32 million US in the last 6 months to clean this up. So, I mean, it's a big problem. There's heavy fines. There's even jail time with it. But as a security professional, I love compliancy because it actually forces people to really look at security, right? Instead of saying, hey, we just deployed that web server out there, well, have you had security look at it? No. I mean, typically security is always the last one brought in, and it's always pretty much of a fire drill. But what's important about this is it's really putting security, up front. And then the whole notion of having less control, right? And again, it's putting this implicit trust into the vendor that you're putting your solutions up in the cloud in. So earlier we talked about the different types of cloud models. So we have software as a service, platform as a service, infrastructure as a service. And as you look at each of these, I mean, there's kind of a different security posture that you can kind of put to these. I know different people might have different ideas of, obviously we want 100% full security on these. But when you look at the infrastructure as a service providers, I mean, they're just providing you the basic infrastructure. So your things such as firewalls, IPS, ADS, et cetera, those type of security technologies would be prevalent. But when we start coming up as platform as a service, now we're running platforms, right? Platforms that do need security. So then your security becomes a lot more elevated. When you get into software as a service, you're dealing with, it's kind of security building on one another. And once you get to software as a service, you're now dealing with applications, you're now dealing with real data, et cetera. I'm sure a lot of you use, well, I'm not sure if a lot of you use, but Google has, Google Docs, spreadsheets, et cetera. I know some people probably use those it could be for very sensitive information that they're not thinking that they're storing up there. But it's important to understand that when you're doing this information is being stored there. So is the channel that we're doing this through encrypted? Is my data that's is it encrypted at rest? Or am I even on the same server as other clients or other users of that service? So when we start popping down, all these things start becoming important, but security can be less scaled down depending upon what you're providing. But as we start popping up to the top, or even from the mid-tier, again, when I focused on kind of how the security equations changed and focused on, the web-based threats and trends that we see from a server and client side, those are starting to become, key focal points for a lot of these providers that are providing both of these different tiers. But what's important to note on infrastructure as a service, and again, in working with Pat O'Day of BlueLock, is giving the clients the capability to layer in the security that they want. Security is not cheap, but giving them the options if they don't have compliancy wrapped around it, what do they want to put? What do they want to protect, et cetera. So this is quite an eye chart, but when we look at managing the risks, I think this is the biggest thing of walking away here is just really understanding multi-tenant security infrastructures and understanding, isolation and why that is extremely important and why I'm trying to hammer that one home is, again, understanding, how are they handling their data? How are they handling their infrastructures? These are questions that you need to ask. They're important to ask, and they should have an answer for you. You talk to the different vendors out there. So, you have Amazon, GoGrid, you have BlueLock. There's a ton of different vendors out there that do provide a lot of these services. But, understanding, the different types of security, cross-domain, virtualization security. I mean, it's almost a given in most of these environments that they are using virtualization because it's just a lot cheaper. It's a lot cheaper, it's more efficient, it's more green. It drives a lot of what we're seeing today, not only in just the traditional wired networks or traditional infrastructures that we see, but when we start getting into cloud, virtualization is getting huge, and we'll go through that in great detail. But again, I mean, all these are just delivered into the different platforms, the different services, and the different resources, et cetera. And then also going down to physical security. We're not going to talk about that, but obviously when you look at a lot of these data centers, even some of the data centers that you might have, obviously there's armed guards trying to get through, et cetera. But I mean, armed guards and so forth are good, but when your front door is my web browser, that kind of changes the security dynamic a lot. So let's build this out really quick. So just kind of summarizing a little bit on cloud, I mean, you kind of have to look at it in these 5 different buckets. A lot of us might deal in very specific areas of security, people and identity access, identity access and management. Those things are really important. I mean, you look at technology that we have to deal with today, people, process, technology, people and identity. I think that is extremely huge. I don't know if some of you remember the Twitter attack that happened about 4 weeks ago. Basically, they were able to hack into one of the executives from Twitter, grab his password, which was a password that was used across all of his accounts. Those things become important to understand that from a people process perspective. But when we start diving down into information and data, so default encryption, data at rest, data in motion, we talk about process and applications, so SLAs that are backed by availability and confidentiality. The biggest thing from some of us that are in security, you don't want security to hamper stuff, so having security on the endpoint can start eating up resources. We don't want that to happen. We have network IPS, for example. A lot of people don't want to put that in because they're afraid that it's going to slow down the availability of the network. So again, another thing that's important to note. Dynamic allocation of pool resources and mission-oriented resources. So again, having the capability for automatic provisioning and remediation of anything that we have out there that has vulnerabilities or has been exploited. And then physical infrastructures, I kind of talked about that just a few moments ago. But again, we're looking at data centers that are extremely fortified, that have armed guards, et cetera. So when you look at security, I mean, it spans a whole different bunch of these different buckets over here. But it's important to note that we have all these different various categories that we can kind of relate them to. But the biggest thing is just pointing out, when we start getting the cloud again, is isolation, 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 right? So we're going to stop on cloud computing and kind of go into virtualization. I'm not going to spend too much time on this one. There's tons of benefits to virtualization. I think we all know these. Obviously, the biggest thing is enabling cloud computing. This has helped a lot of companies come up online very quickly, deliver applications, deliver whatever services they want to do extremely fast. It's green. It's helping a lot of companies in this economy keep growing. It's helping people who don't have money to buy data centers, et cetera, to start, et cetera. So this is kind of at a high level of the different, the benefits, but I think a lot of us know those. When we start looking at virtualization, security 101, so obviously, everything, we had wires, routers, switches, servers on racks, everything was physical, we can touch them, et cetera. Now all that's in a box. Everything, the network, the virtual machines, if they're moving around, do we have virtual machine sprawl, et cetera. So and then who's responsible for the security of this, right? Because typically when we start looking at different infrastructures that we go in, you're either dealing with the networking team, you're dealing with there could be some legal teams you're dealing with, your server teams, et cetera, right? Security is you have different the different organizations in the infrastructure that you have to deal with. Now all this comes down into one device, right? So now you have a server admin who's doing network administration, et cetera. So it is getting more complex, right? You can reduce costs by doing this, right? But it absolutely adds in a lot more complexity, and we'll go through some of those. Because what's important to note is understanding how do we manage risks of virtualization. So when we look at this, there's actually 5 different areas. We're really not going to touch too much on the hardware area. But when we start breaking this out, there's different areas that we need to focus on and have an understanding that, there are some traditional threats that don't go away. And it's not funny, but I mean, there was a survey that was done on virtualization that went out, and I think it probably went out to a lot of people that were just generalists in security, but asking them if they thought, well, say, since I'm virtualized, I must be a lot more secure than I am being, just in a regular infrastructure. And it was interesting to note that probably about 60% of the surveys that came back thought that just because they were virtualized, they're a lot safer. Well, your applications and operating systems have no idea that they're being virtualized. some exploit code does have that capability. We'll talk about virtual machines. We'll talk about VM stealing, dynamic relocation, why that's considered kind of a risk. We'll talk about the hypervisor, and then we'll talk about the management plane a little bit. So we'll kind of bust into each one of these. So when we start looking at operating systems and applications, all these threats remain the same. Buffer overflows, SQL injection, cross-site scripting, data leakage, all these are still fair game and are still out there, regardless if you're virtualized or not. We start looking at some of these other things when we start coming down is, it doesn't, when we start looking at OS and application threats, again, we've seen pretty much of a downturn on just direct target attacks against the OS because it's so much easier to get through the web applications or through the web browser, et cetera. But again, when we start looking at, what are some of the risks? Well, this one absolutely still remains the same. When we start looking at virtual machines, we start getting into, compliancy and patching. The ability to spend or activate VMs. This is great. You can shut them down, but if you have a bunch of VMs that are shut down, it could alter the update streams in the event there's something that's out there that's pretty catastrophic, configure, et cetera. You name the exploit of the day. If you start talking about virtual sprawl and identification, so keeping track of the VMs, depending on how large your organization or infrastructure is, these become important. But again, when these are in the cloud, these are things that are really not things that we're really worried about as a user of the cloud. But as a provider, these are things that are really important. Live migration. So are some of these moving to less secure VMs? Is there less of a security footprint that's on some of these systems? Are they placed at risk? Some of the static security policies no longer apply. So again, these are some things to keep in consideration when we start working around the little risk metrics of virtualization. And what's also important to note is, we're talking about server virtualization. I did a talk actually last week and Friday at the Red Hat Summit on securing virtual desktop infrastructures. And some of the same stuff absolutely applies, right? The good thing about VDI is, the data is not on, for example, if it's on your laptop, right? It's being stored up in the cloud. So some of the compliancy, some of the data leakage concerns that are applicable, really play out on that. So when you start looking at, well, is this the same for VDI? It's almost identical. Replay attacks. So I have a kind of a demonstration on the next slide that kind of talks about that. Are there capabilities of replay attacks or actually stealing a VM in motion, which is kind of trivial. If someone's stealing your VMs in motion like this one, I don't know if some of you are familiar with the Zen exploit that was done. But basically what this does is, either vMotion or doing this via live traffic migration, right? No big deal. But a university was able to kind of do a man in the middle, reset a couple commands, and then they had access. So it's important to note, when you have vMotion or have these things, obviously all the vendors recommend to do this in an out-of-band network. This can be encrypted as well. So what's important to note is, even though this is trivial, this was done at a university, it can be done. The likelihood of this happening is probably very, very slim. In the event that it did, then I think you probably have a much bigger problem than that. And that's one thing you'll see. From a security community, we'll see a lot of proof of concepts, which are excellent and fantastic. What are the likelihood of some of those actually really happening? This is a possibility, but again, if you take the precautions in as far as doing it out of band and doing it encrypted, the chances of this happening are fairly nil, or it's reasonably secure to do it that way. So when we start getting into the hypervisor, single point of failure for attack, we're kind of going back again. When you start remembering when we first came out with the data centers, we had multiple applications on one server. So if one application went down, it could bring down the whole entire stack. So we started coming out with 1U appliances where we can have our application server, mail server, et cetera. Everything was separated and segregated. Now today we're going kind of back to that model, right? Where we have the hypervisor that is basically hosting out a lot of different applications. But not only is it doing just from an application perspective, it's also doing traffic, right? It's also doing, basically your very minimal, L2, L3 routing and switching, And the other thing too is guaranteeing isolation. So this kind of coming back to SE Linux and SVirt, why isolation is really important is, basically you can have some form of isolation, between both of the virtual machines, right? But using SE Linux and SVirt, it's quite possible with different labels to even actually have it separated down in the hypervisor from the perspective of inter-VM traffic. And those become really important. So if I can stress a lot, when you start looking at the isolation technologies, SE Linux, SVirt has an incredible way of doing this. I know VMware and others do as well. But those are things to kind of look at, because Zen, and you can download a lot of these things for free. You can play with them, understand them. Obviously with SE Linux, as some of you are familiar with Secure Solaris, or Solaris 10, it's kind of, I would say, kind of the same thing. It's not that complicated to configure. But again, when you want separation and isolation, these things are important to understand, and understanding the risks of not having that in a multi-tenant environment. So when we start looking at the hypervisor as well, if you look at VMware ESX3, it has 2 gig surface. There's millions and million lines of code. Doing some more research, looking at ESX 3.i, they reduced the surface, reduced the amount of lines of code. This is good and bad. It's good to the fact that there's probably less there to probably exploit. But when we start looking at the different services that we do provide, it provides full networking capabilities, communications. We look at other services, so we have VMsafe, so those APIs for hooking in security into the hypervisor, disaster recovery, vMotion. So there's a lot going on here. And again, when we start coming out of, this is basically our infrastructure in the box, because we're able to do everything from one centralized location. But again, in doing that, there's a lot of risk. There's a lot of blind spots that you're not able to see from a security perspective. And then we start going into the management infrastructure. So at the very beginning, I kind of talked about the web threats, why those are important to understand. So everything that we configure today, obviously a lot of us in this room do command line, I do as well, but a lot of the systems that we're given today have web interfaces. So a lot of those attack vectors and threats and trends that I've talked about are still applicable to the management interface. Obviously management and having access to it can give you access to the virtual machines, the management data, etc. But what's even more important to just the software threats is not ignoring the operational threats. Because again, virtualization is not new. IBM's been doing virtualization since the 60s. Virtualization kind of came back in 99 with VMware, a lot of it being used. I used it extensively for research and R&D. But now people are actually using it for type 1, type 2 virtual machines. But the operational risks are, you have a lot of these new technologies that are coming to bear, and it's understanding what the skills and expertise are needed to configure it, right? But not only to configure it, but understanding what are some of the operational threats and security threats that wrap around that. So some takeaways just on virtualization. Obviously it introduces significant operational risks. We talk about the different risks from a security perspective. I kind of went through the different 5 areas of virtualization with the exception of hardware. But there's different risks that it introduces to the network, or introduces to the, into the cloud and into the infrastructure. All these can be mitigated to some degree. From our perspective, from our R&D, obviously we've seen a massive rise in vulnerabilities due to the fact of x86 virtualization is somewhat new. I've seen a lot of people here using Apple laptops. This is in our trend report as well, but when you start looking at technologies that start getting used, obviously from the community, from the cyber actors that are out there that are black, gray, white hats, etc., those things become targets because they're targets of opportunity, targets of, I guess I'd say low-hanging fruit. But these are just some key takeaways I take from virtualization, because again, virtualization is heavily baked into the cloud and as we're moving forward. But when we start talking about embedded virtual security, how can we look at it and how can we actually start putting in some more security? Obviously, again, isolation is going to be huge, but having scalability, being able to grow and shrink the different security footprints that we have here, and understanding, where does security fit in, right? Security can fit into the same layer as a guest, right? And we've seen a lot of vendors out there that have put out a lot of different security. It could be intrusion prevention, firewall, et cetera. That's actually even hanging out at the guest level. That's one way of doing it, right? So having the capability of doing deep packet inspection, so being able to be on the vSwitch and being in the middle of the vSwitch and kind of looking at the traffic as it's going back and forth, right? So you can have, one that's a web server, one that's a database backend, so your front-end web's here, but actually having some separation there and being able to look for any type of vulnerabilities or exploits that are crossing into an area that you have no visibility into seeing. And then not forgetting just from the network perspective, but actually moving up into the host, looking at anti-rootkits. So there is a lot out here. Again, all these are still applicable because now, again, it does not realize that it's being virtualized. But again, being able to prevent these attacks and being able to prevent them not only just at the guest access layer, but also at the hypervisor. So when we start looking at security virtualization today, we look at first generation, right? So, install security on every single guest. That scales to some extent. Applying your defense in depth, so all the things that we learned from a defense in depth perspective, still apply in virtualization. This still applies in the cloud, no matter where you're at. Locking down the management interfaces, all these are nothing new. Segment the networks out with VLANs, right? Using standalone security appliances that are baked in. And then we start looking at some of the different limitations. So, new VMs that come on there do need security provisioning. And then as we start adding on more security, obviously we're taking up resources, right? And the biggest thing when we start looking at virtualization is supposed to help us with resource allocation, et cetera. But as we all know with security, obviously it does introduce some form of resource allocation or resource stealing. So when we start looking at kind of fixing this, same thing with the hypervisor. So all these things are good, but I think we can do better from a security perspective. How we look at how we want to do security tomorrow from a next generation perspective. So again, applying your defense at depth, shrinking the management stack. So installing a security VM on every machine that's actually in there, right? So using like the VMware APIs, for example. But having centralized network protection. Everything that's basically agentless, right? Where security is not an afterthought, right? Where security is absolutely baked into the virtual infrastructure. You can have additional security with TPM, right? Which is basically like a trusted computing model. So basically having multi-layered, multi-level security. So when we start looking at securing virtualization, I guess the challenge out to the vendors for us to do this is how can we move security, into the hypervisor or in there so it's basically agentless, right? That's where probably we should see security going because it takes less off the host. Security does not become an afterthought, et cetera. So threat and compliancy landscape. We went over that. Key walkaways, and a lot of you are probably very familiar with the threat landscape when it comes to browser-based and server-side attacks. Those are prevalent. They're always going to be growing. Is cloud computing safe? I would say it is. It depends on who you're using and the questions that you're asking. As Al mentioned before earlier, Gmail, Hotmail, AOL Instant Messenger, we use a lot of those today. Would I be willing to put up my personal data up in the cloud? Yeah, I would. Virtualization, something old, something new. It's nothing new. It's just a new way of doing computing that saves money. But with that comes additional security risks, and we kind of went through those. And then changing the security paradigm. Where we're constantly out here layering security on everything that we build, right? From a vendor perspective, we have to do it a lot differently and going in the future. And virtualization, a lot of other key components within the network infrastructure are going to be important for us to make sure that we're able to change that paradigm. And that's it. I'll take questions.
We've been doing Q&A sessions because some people fall asleep and some people don't want to ask questions unless I go on stage and help them. So I've figured out a few questions that I want to ask you. I mean, cloud computing, virtualization and stuff, I mean, it's mostly for increasing availability for your system, lowering costs, for handling stuff like that. It's first, doesn't all that, I mean, as soon as you start increasing availability, don't you just lower the level of security in other areas like, you know, confidentiality, integrity, and stuff like that inherently?
Not really. I mean, when you start adding in the more resource sharing, but it depends if you're talking from a multi-tenant perspective, right? And depending upon isolation, encryption, you know, what's going on. I think inherently, yes, but I mean, I think when you take in consideration or take into account the different type of mitigation technologies that you can have in there, it really doesn't lower your security posture. I mean, it could, but you know, the capability for resource sharing. So you're talking about like shared memory and so on and so forth. I mean, you know, academically, yeah, I mean, you're sharing the same resources that you can actually grab information from if you actually had physical access. But I think when we start looking at it from a cloud perspective, I mean, you have no idea where the resources are coming from, where they're going. So, I mean, if you have a security posture that you started with that was, I would say, positive, I don't think that would be deprecated in any way. In the event that we talked about vMotion, or in the event you had suspension where you're pulling up new virtual servers, et cetera, that's where you can get an instance where you have a deprecation of your security stance or effectiveness.
Right, and every time I see these slides of people building virtualization and cloud stuff, it does look like you're supposed to build everything from scratch. I mean, you can build everything with all new components, stuff like that. Is that really real? I mean, doesn't people just try to move their existing environment into a virtualized environment, bringing all the security problems they already have?
Exactly. I mean, all your same security issues that you currently have in your traditional infrastructure today, all those will come over with you in virtualization. But what's important to note is with virtualization, now there becomes even more risks that you have to deal with, the ones that I was talking about. So, you know, what's really good about that, though, is there's a lot of lessons learned, right, that we've learned in the, you know, however long we've been doing information security, of all the things that we could do wrong, right? So all those things kind of transfer, things we can look back that we shouldn't have done, that we should actually do when we start going forward. And I think what cloud and a lot of these talks right now is really bringing security to the forefront, because it's becoming more important just because of the type of data that people are wanting to place in the cloud, right? So yeah, you're gonna bring a lot of those same security problems with you, and I've, you know, talking around the world in Australia, Japan, EMEA, et cetera, I mean, those are a lot of the questions that I get asked. They're like, well, I'm transferring everything here. It's all the same. And well, it is, right? But I think what's happening now is people are taking more of a strong focus on security, which is awesome for the community that we have here. But it's the lessons learned that we can actually transfer in the cloud and make it even a secure place to do business.
Right. And also, there has to be a lot of legal issues about who owns the data when you're starting moving stuff in, you know, starting moving your data into cloud services. I mean, do different countries handle that differently? I mean,
no, absolutely. So, I mean, you have a lot of different countries. I talked about Luxembourg, for example. You have Canada. I'll use those for examples, but none of their data can traverse our country borders, right? So what does that mean from a cloud perspective? Well, what that means is, you know, the data centers that's housing their information can only reside, obviously, in their country, right? But when you start looking at, you know, I'm out of the country right now, right? How I get back into IBM and dialing back in through a VPN, right? So, I mean, it's kind of a cross-border, but I'm still using security to go in. It's basically where the data resides at, where the data's staying at. So there's a lot of different regulatory compliance, and you brought up, you know, a big one in different countries that have those different type of controls in place. But those are things to take in consideration as far as, you know, obviously, you know, working in this country or working in Luxembourg, they have their own data centers there, and that's what they're able to do. But like from a Canadian perspective, you know, we see that all the time, because within IBM we have MSS services, which is basically almost some semi-cloud, right? But you know, we cannot do anything in the United States in our Atlanta SOC in Atlanta, Georgia. We have to do things that are up in Canada. So it changes that paradigm around a little bit, but there's been more and more focus on regulatory compliance. But what we see in the United States is, I mentioned PCI, but we have HIPAA, GBLA, SOX. There's a lot of different requirements that are levied. So depending upon what industry vertical you're in, depends upon what type of data you're putting up in the cloud. But as I mentioned earlier, with PCI DSS, Amazon just came out and said that they could host tier 1 PAN data, right? So that's showing me that they have all the checks in place, but it still garnered me to ask those same questions. What do you have from a security perspective in there?
Thank you. That's the questions that I have. Do you have questions for me? Oh, Thomas.
Yes, I have a question. A lot of people don't want to care about security because security is cost.
Right.
So I've seen examples of where you're seeing cloud as an easy ticket out of security. It's like, no, it's not our system. We don't have to care about security because it's in the cloud. We just buy the service. So it's actually Amazon that should care about the security of our data. How can you handle that when you go into virtualization? Or should you handle it? Or should actually the provider handle it?
I think that it should be handled by SLAs are asking the question. I mean, I think security is probably an implicit trust that they have that. And it's a question that what you're asking is always, it's not my problem, right? I mean, that's why I outsource everything. You take care of it. I don't even want to worry about it. But from a security perspective, just because of security is making the news more and more every day, obviously with social networking, et cetera, a lot of clients that I've talked to are asking those questions or, encouraging them to go back to Amazon, GoGrid, et cetera, to ask, understandably, but, how is my data secure, right? So in the event that I do get breached, then what's the SLA on that? For example, we provide SLAs for us in the event if you're using our equipment and if you get hacked, we pay out a substantial amount of money back to you, right? So our SLAs are fairly tight. I think those are some of the questions that you have to ask, and a lot of it's questions. But but backing up, we have that 80-20, right? We have the 20% of very technical, smart people here that can ask those questions and understand what's coming back, right? But you have that 80% that would do the implicit trust, and I think that's probably a lot what we see of. So that's a good question.
More questions? No? Yeah. You want to use the microphone?
Hello? Yeah, as I was saying, I've been trying to sit here formulating a question, so please bear with me as I try and ask this question. Looking through this presentation and listening to what you're saying, we're introducing a significant amount of complexity. Mm-hmm. All of this complexity requires more time to think of how we want to plan our infrastructure, how we want to plan our virtualization, our private clouds, so maybe we want to do a bit of public clouds. In terms of money invested moving to a cloud infrastructure, are we actually reaping the benefits money-wise, or are we actually losing out because we spend so much time migrating, talking about what we need to do? We need to implement this now because we need to have VM introspections, we need to have this and that, and so forth and so forth. Do you see what I'm getting at? That if we just start with what we have and then...
No. It's a good question, right? So the question is basically, I'm introducing a lot of complexity. Virtualization does that. But the whole thing is reducing cost, right? I think initially you start looking at all the FTEs that takes to do all the migration, all the setup, the planning, security. That's expensive, right? I believe there's an upfront cost that you're probably going to have to swallow. But if you look at the long term of doing it right over several years, et cetera, I think the cost benefit is could be a lot cheaper depending upon how big your infrastructure is. But it's not a matter of I'm going to take my entire infrastructure today and I'm going to throw it in the cloud, right? I think it's a matter of, what parts can I offload and what makes sense, right? What can reduce my CapEx cost? Because what I'm seeing today, just from a security perspective and talking to corporations worldwide, is they have limited money, right? And how are they going to save money to where they can actually purchase different things inside their infrastructure? So, you bring up a good point. There is a lot of complexity that this brings in, right? There's a lot of cost for taking the individuals, the men and women that take to move all your data out. But I think once you have that and that's running, once you have that infrastructure up and running, for you to expand, grow, et cetera, those things become a lot more easier. But to answer your question, I mean, yeah, it is more, if someone were to tell you that virtualization is not complex, it absolutely is. But I don't think there's a real answer to your question, but I know that, in talking to different corporations that have done it, they've done it in I would say piecemeal at first. I've never seen any infrastructures, and there could be out there that have taken everything and uprooted it. But what I've seen is just very little things that they have offloaded, and a lot of it was due to costs, and then understanding, well, I'm moving this section of data off, do I have access to it anymore? Or am I willing to let go of that? So I don't know if that answers your question, but is that what you're dealing with in your?
Well, I wasn't looking for an answer because I don't think there is one. I was just curious whether one has done any actual try to analyze the amount of money you spend migrating and moving, and I just feel that the increased complexity that we have, and also considering that companies today have barely understood why they should have basic firewall rules and just the simple stuff. Mm-hmm. Now we're talking about even more complex stuff that they definitely do not understand. And I'm just wondering if this is a cool thing to talk about, but are we actually gaining anything from it?
Yeah. I mean, I think, no, it's a good question. I mean, I think there is positive gain to it. And you bring up a good point, right? I mean, firewalls, right? I can't tell you how many times you've been around the world where people are like, that's all I have and I'm protected, right? We all know that that's not the case, right? It's more an educational perspective, right? How do we educate the masses? Like I said, I mean, everybody in this room is in that 20%. I mean, we could sit down and we could talk about this all day. You understand that, right? But it's the people that don't know that, and it's constantly educating around the world. Well, firewalls are good, but this is why you need this, right? Oh, cloud computing virtualization is also good, right? Oh, by the way, here's all these risks that are tied with it. So I think as we start going through this, I think a lot of it is going to have to, it's going to be education, and it's going to be great opportunities for all of us here in the room to take that challenge, to go out and basically either give that message and or be the ones that are securing these next generation infrastructures. I don't think it's going to go away, but I'll leave it at that. It was a good question.
Actually, I was in terms of just to give you a little bit of analysis on it. It's in the U.S. we've been finding that probably we could have about 70% savings on power, and in terms of if we virtualized most environments, just because of different amounts of overhead. So I mean that's usually the basis that we use for virtualization, and then you take a bunch of different other things, and you sort of say, well, there's going to be the complexity, but I mean that still leaves you, if you take 3 or 4 years out that you paid for it, then you suddenly have all that money for security or other things that you want to focus on. So
that's good. I mean, yeah, I mean, power.
Question, I'm sorry.
No worries.
Do we have any more questions? No? All right. Thank you, John Pearson.
Thank you.